Good morning everyone. Welcome to today's maths class. Let us recall what we have discussed in the previous class. So we learned how to find the height of an object which is at a distance by using applications of trigonometry. Okay, we have taken one example, that is we found the height of a building which is at a distance of 480 meters and the top of the building was observed by 60 degrees. That was found by using the trigonometric ratios. So with that knowledge we can do many problems from this chapter, that is applications of trigonometry. Okay, before we get into the problems, let us revise some basic points which are very useful for the problems in the applications of trigonometry. Okay, now look at the board. Here there are three definitions: line of sight, angle of elevation, and angle of depression. Okay, we have already discussed these points in the earlier class. Let us discuss once again. For example, if I am looking at an object like this, so I am looking straight at that object, then the imaginary line from my eye to the object is called the line of sight. Okay, so if it is straight like this, it makes 0 degrees. The line makes 0 degrees with the horizontal. Okay, that is the horizontal line. If I keep the object at some height and if I look upwards like this, the line of sight is above the horizontal. And if I am looking at the same object which is downwards, so to look at that object I need to look down. Okay, which is downwards the horizontal. So either we can look straight to look at an object, otherwise we have to raise our neck, otherwise you have to down your neck to look at the object. Based on that, we can call them as either angle of elevation or the angle of depression. Okay, first of all, let us discuss what is a line of sight. Okay, a line drawn from the eye of an observer to the point in the object observed by the observer is called the line of sight. So, for example, if there is a flower, and a person looking at that flower, from his eye, if he looks like this straight line from this eye to this flower is the line of sight. Okay, the direct line from the eye to the object, it may be anything, is called the line of sight. Look at the first picture, see the figure 1 for the first diagram, for the second one here, and the third one here I have drawn the diagrams. Now look at the first one. What is the first one? Here O is the observer and object is at A. Okay, now the line from O to A is the line of sight. It is very simple to understand. Now, so this is the first one. Now look at the second one. Angle of elevation. Okay, so the angle of elevation of the point viewed is the angle formed by the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. Means the object which is above the horizontal level, if you have to look upwards to see that object, then we have to raise our neck. That means the angle has been increased a little bit towards upwards. Okay, in that angle, for example, see this is the horizontal line. See, the angle has been raised upwards to look at the object. The line of sight is above the horizontal line. It is above the horizontal line. Then the angle is called the angle of elevation. And see, so for this second definition, you have to draw this diagram. Okay, so just draw the diagram just beside, right side of the definition. As I don't have enough place, that's why I have drawn like this. Now, look at the third one, angle of depression. If the object is below the horizontal means just straight from our eye. If you look straight, that is the horizontal. If you look downwards to observe an object, then, for example, see, the angle of depression of the point is the angle formed by the line of sight with the horizontal when the point being viewed is below the horizontal line. See, look at this. Here the observer. So, in this case, the observer is at top of a building or above at the top of a tower like that. Okay, so he is observing a point object at the down, that means on the ground A. So he is looking downwards. If you look straight, the horizontal line forms from his eye towards directly with the 0 degrees. If he looks down, the angle comes down like this. The angle so formed is called downwards, is called the angle of depression. Angle of elevation means upwards and the angle of depression means downwards. Okay, you copy these three definitions along with the diagrams. Okay, then we will go with the problems from the exercise 9.1. Now look at the first problem from the exercise 9.1. A circus artist is climbing 20 meters long rope which is tightly stretched and tied from the top of a vertical pole to the ground. See, here I have drawn. Here, let us consider this is a rope, and on the rope a man is walking, a circus artist. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Now look at this. Actually, this rope was tied to the top of a pole. A pole is like this. So generally circus people walk on a rope. Have you ever seen? So like this he was walking on the rope. So this is a pole AB. AB is a pole. And the rope was tied to the ground and also the other end to the top of a pole. Okay, and see, the length of the rope is 20 meters. He has given 20 meters. Okay, and obviously this angle will be 90. Why? Because a pole, vertical pole. So always we have to take the building, tower or pole, anything, we have to consider they are all perpendicular to the ground, vertical to the ground. So this angle will be 90. And he has given another point that the angle made by the rope with the ground level is 30 degrees. And this angle is also given. How much it is? This is 30 degrees. And the length of the rope is 20 meters. Okay. Now, what we need to find? We need to find the height of the pole. The height of the pole is h, that is unknown. We need to find this. Okay. So this is the problem. How to find? So observe, from the given information we have got one right angle triangle. Let this point be C. So ABC right angle triangle where angle A is 90 degrees, angle C is 30 degrees. Let us write the information first in problem number 1. In triangle ABC, angle A is equal to 90 degrees, BC is equal to length of the rope. How much is given? 20 meters. And angle C is equal to 30 degrees. This is the information given. Now we need to take the ratio between unknown to known. The ratio between the sides of unknown and known side. So which one is the unknown value and which we have to find it out. That is AB. We need to find the height of the tower. So AB is the unknown. And which one is given? That is BC. BC is given. How much it is? Let us arrange this. So how much it is? BC is given 20 meters. So unknown, known. So ratio tan theta is equal to AB by BC. You may get a doubt, why do we have to take tan only? We have 6 trigonometry ratios: sine, cos, tan, cosecant, secant, cot. Actually, always we have to go with sine, cos, tan only. You don't need to go for the remaining 3. Why? Because those 3 are the reciprocals of these 3 ratios. Always we have to look one among those 3. And why do I have to take only tan? Because, sorry, very sorry, and AB is the opposite side. Here AB is the, which side it is? Opposite side. And what is this side? Hypotenuse. So opposite and hypotenuse. What is the ratio among them? Here unknown value is H. Here known value 20 is hypotenuse. Opposite and hypotenuse. Which one we have to choose? Sine. So why do we have to sine only among those 3? So we have unknown value opposite side, known value hypotenuse. The ratio between opposite and hypotenuse is sine. So we have to take sine theta is equal to opposite side AB by hypotenuse BC. Now this implies, what is the angle given? The theta given is 30 degrees and AB value which is not given, which we have to find it out. And what is the BC value? BC value is 20. So this implies sine 30 value is 1 by 2 and H by 20. By doing the cross multiplication, 20 into 1, 20 is equal to H. 2H is equal to 20. Then H is equal to 20 by 2 is equal to 10 meters. Therefore, height of the tower is equal to 10 meters. Okay, did you understand? Now let us write this at the middle. Okay, so for every problem it is very important to draw the clear picture. So from the diagram we have to gather the information and solve the problem. Okay, please copy this. Now let us go with the second problem. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Okay, see, look at the picture. Here there is a tree. We need to find its height. The height of the tree we don't know, that we need to find. Okay, and it was broken due to storm. So big blow of wind. So it was broken and it was fell down like this. Okay, so then it touches the ground at a distance. So for example, it breaks like this and the broken part fallen like this and it touches the ground at a distance. Okay, see, then it touches the ground at a distance and making the slanting part which was fell down, making an angle 30 degrees with the ground, and which touches the ground from its base at a distance of 8 meters. Okay, did you understand? The tree was broken, the broken part fell like this, and here angle made was 30 degrees. The distance where the broken part touches the ground is 8 meters from the foot of the tree. Then we need to find the height of the tree, the total height of the tree. Okay, now see, let us draw a geometric picture for this data, then we can understand the problem very easily. For example, see here, this is the unbroken part which stands like this without any break. And the broken part, let us take like this, and it touches the ground at a distance here. Okay, the base is, let us take the base. The base is this one. Okay. Now let us consider the tree is vertical to the ground, which is making 90 degrees with the ground. So this angle is 90. So AB is unbroken part and BC is broken part. What is the angle here it is making? Here this angle is 30 degrees. So we have to take 30 degrees. And what distance from the foot of the tree it touches the ground? That is also given. That is 8 meters. This is 8 meters. Okay. So then we need to find the height of the tree. How do you find? Okay, see. Now let the unbroken part of the tree be x meters. See, unbroken part which stands vertically, the part which stands vertically, let us take it as x, and the broken part let us take it as, okay, y. So to find the total height of the tree, for example, it was broken here, this is x and this is y. So if you want to find the total height, we need to find x plus y. So we need to find the values of x and y separately, and then we have to add them to get the total height of the tree. Okay, so let us do this problem with the help of geometric diagram. Okay, now look at this. Okay, now question number 2. In triangle ABC, AC is equal to length on the ground where distance from the foot of the tree to the top of the tree, so where it touches the ground. Okay, and what is AB? AB is equal to x, that is equal to, what is that? Unbroken part of the tree. And what is BC? BC is equal to y. Let AB is equal to x and BC is equal to y, that is equal to broken part of the tree. Okay, so I have told you that we always, when after the finishing of the diagram, we need to search about the known value and unknown value. So there are two unknown values, x and y. First let us take this unknown value and this known value. So this is the opposite side and this is adjacent side. What is the ratio between opposite and adjacent? Tan. So tan theta is equal to opposite side AB by AC. This implies, what is the angle given? So that also we have to write. Angle C is equal to 30 degrees. 30 degrees is equal to AB value x by 8. So tan 30 value 1 by root 3 is equal to x by 8. By doing the cross multiplication, we get root 3x is equal to 8. Therefore x is equal to 8 by root 3. Say this is 1. This is the first part of the problem. Okay. Let us do the second part here itself. Now we need to find the y value. What is the side in this triangle? What is, as per this position, what is y? Y is the hypotenuse. And known value, this is adjacent to 30 degrees. Okay, so we have to take adjacent and hypotenuse. We have to take cos. cos theta is equal to, what is this? Adjacent AC by BC. So this implies cos theta value 30 degrees and AC value 8 by BC value y. So what is cos 30? Cos 30 value is root 3 by 2. That is equal to 8 by y. If you do cross multiplication, you will get root 3y is equal to 16. Therefore, y is equal to 16 by root 3. This is equal to 2. Okay. So now we need to find the height of the tree. So actually we can write this part down on this one, as we don't have the enough place. I have written like this. Now therefore the total height of the tree is equal to x plus y. X is equal to 8 by root 3. What is the x from 1? 8 by root 3. And y value 16 by root 3. If you add, you will get 8 plus 16, 24 by root 3. So we should rationalize this. Why? Because we have the irrational number in the denominator. 24 by root 3 can be rationalized by multiplying root 3 in the numerator as well as in the denominator. Now 24 root 3 by root 3 into root 3, 3 8 is 24. We get 8 root 3. As the root 3 value has been not given in the textbook, in the question, we don't need to substitute and simplify. You can leave like this. Therefore, height of the tree is equal to 8 root 3 meters. Okay? Did you understand? Now, if you can draw the perfect picture for the given information in the question, it is very easy to get the answer by applying the trigonometric ratios. Okay? Now, let us continue the problems from this exercise in the next class. Thank you. Have a nice day.